So, moving on from similar shapes in 2 dimensions, looking at the length scale factor, we're now going to look at what happens with similar areas and similar volumes. So, the length scale factor, or the LSF, we refer to as K. So, the area scale factor, or ASF, is going to be K squared, and this is going to tell us how big or small the area of one shape is compared to a similar shape. So again, the shapes need to be similar before we can apply K squared. For volume scale factor, it makes sense because it's cubic units that our VSF is going to be K cubed. And this is going to tell us how big or small the volume of one shape is compared to a similar shape. So the strategy for finding missing areas or volumes is to get the scale factor K, then work out K squared for area or K cubed for volume, and then we're going to multiply K squared by a given area, or we're going to multiply K cubed by a given volume. So first step, work out the length scale factor, and then figure out whether we're working with area or volume. The units in the question normally help us with that because squared units are always area. If it's cubic units or if it's milliliters, which obviously is the same as centimeters cubed, or liters, and there's 1,000 centimeters cubed in a liter, then we can use the volume scale factor. So, our example. We've got 2 dolphin-shaped fridge magnets that are mathematically similar. If the area of the smaller magnet is 18 centimeters squared, find the area of the larger magnet. So if we annotate our picture here, we know that the area of the smaller magnet is 18, and that's A old, because we want to work out A new, and that's our unknown. So we know to work out our scale factor, we have to do new over old. So the first thing we're going to do is say that K equals 10 over 4. And we can simplify that down to 5 over 2. Now it's area, centimeters squared, so we're going to square it. So we need to work out what K squared is. And that is 5 over 2 squared, which is the same as 25 over 4. And the final step is to work out what our A new is. And we're going to take our K squared, which is our 25 over 4, and we're going to multiply that by the area of the small magnet, which is 18. And that gives us an answer of 112.5 centimeters squared. So our next example, we've got 2 model airplanes that are mathematically similar. And you can see the corresponding sides are the lengths of those model airplanes. We've got one model airplane that's 4 meters long, and we've got another model airplane that's 30 meters long. Also, the picture tells us that the volume of the larger model is 973 meters cubed. So we want to work out what V new is on the smaller airplane. So remembering that our scale factor, we first need to work out our linear scale factor or our length scale factor. So for this one, K is going to be, and we're going to have new, so we're wanting to work out the small volume, so it's going to be the small number over the big number. Now volume, you can see the units there are meters cubed, so we want to work out what K cubed is. So K cubed is going to be 4 over 13 cubed. And obviously with a calculator, we could just put that into the calculator as 4 over 13 and cube it. If you don't have a fraction button, make sure you put the 4 over 13 or the 4 divided by 13 inside a bracket so that you cube the whole thing. And that comes to a value of 64 over 2,197. And then we want to work out what V new is. And so that's going to be our k cubed, our 64 over 2,197, multiplied by the volume of the large model. Now, the question is telling us to round to 1 decimal place. So we need to make sure that when we're writing the answer from our calculator, that we write down at least 2 decimal places. And then we can do our rounding. So we're looking at the 4 and deciding what to do with the first decimal place. As it's a 4, we're going to leave it alone, and so our answer is going to be 28.3, and our units are meters cubed. So the final example for this video is looking at two vases that are mathematically similar, and you can see the corresponding heights of these vases are 12.4 centimeters on the small vase and 19.3 centimeters on the larger vase. Now it says in the question that the cost of each vase is proportional to the volume. So you can see there that the small vase costs £3.07, but we're using our volume scale factor, or k cubed, in order to work out the cost of the larger vase. So if we go back and annotate our picture, we know that the small vase costs £3.07, and we want to work out what V new is in terms of the price rather than the volume of the vase, but it's proportional to the volume. So we're going to have it big over small for our k value. So k is going to be 19.3 over 12.4. Now k cubed is going to be 19.3 over 12.4 cubed. Now, when you put that into your calculator, it changes it into a decimal. Don't round that decimal. Use the answer button on your calculator, or you can just put that k cubed into your calculator as part of you working out what the new price is going to be. So I'm going to put into my calculator 19.3 over 12.4 cubed, and I'm going to multiply that by the £3.07. Now, when I put that into my calculator, I get 11.575. And again, you know that money has 2 decimal places, so to round it to the nearest pence, we need to have at least 3 decimal places. And then we need to make sure we've got our units, and it's £11.50, and it's a 7, and the 5 is after it, telling us to round it up to 8. So our final answer is going to be £11.58.